What if Haaland did not destroy Brazil with power, but because one defender solved the geometry 0.2 of a second too late? Norway beat Brazil 2-1, and Haaland scored twice near the end. The first looked like classic Haaland. A cross, a towering jump, and a header before the defense could reset. The second looked like pure force. But power only explains what happened after the ball reached him. The real mystery is why Brazil allowed the meeting point to exist. Start with a simplified model. A cross travels 12 meters at 24 meters per second. Time equals distance divided by speed. 12 divided by 24 gives 0.5 seconds. Every defender has only half a second to solve the flight. Now place Haaland 3.6 meters from the landing point. If he attacks at 8 meters per second, his running time is 3.6 divided by 8. That gives 0.45 seconds. Haaland reaches the target just before the ball. Place a Brazilian defender only 3 meters away. The defender appears to have the advantage. 3 meters is less than 3.6. The shorter route should win. But football is rude to simple arithmetic. The defender first has to recognize the cross, turn, and choose the correct point. Assume that decision costs 0.2 of a second. He now has only 0.3 seconds before the ball arrives. Required speed equals distance divided by remaining time. 3 divided by 0.3 equals 10 meters per second. That is the speed he would need after reacting late. Haaland needs 8 meters per second. The defender suddenly needs 10. The closer player has become the slower solution. But reaction delay is only the first layer. Direction also removes useful speed. A defender may run at 8 meters per second, but not all of that velocity points toward the landing point. The useful component equals speed multiplied by the cosine of the angle. If he moves at 60 degrees to the cross, the cosine is 1/2. Only 4 meters per second closes the gap. At 4 useful meters per second, covering 3 meters takes 0.75 seconds. Add the reaction delay, and the total becomes 0.95. Haaland arrives in 0.45. The defender arrives half a second later. That is not a duel anymore. That is a calendar error. Now add the jump. Suppose Haaland's contact point is about half a meter higher than the defender's reachable point. The defender must arrive earlier, jump sooner, or clear the ball before it enters Haaland's vertical control zone. If he is already late on the ground, height makes the problem worse. Treat each player as having a reachable region. On the ground, it expands like a circle. In the air, it becomes a volume. Haaland's speed and height create a larger three-dimensional target zone. The cross only needs to enter that zone before the defender's zone overlaps it. The scoring condition is simple. Haaland wins when his reaction time plus travel time is smaller than the defender's, and when his reachable height is greater at contact. Using our simplified numbers, 0.45 is smaller than 0.95. Haaland reaches the point first. His higher contact zone gives him the final advantage. Why can 0.2 of a second cause such destruction? Because the error grows while the ball keeps moving. At 24 meters per second, the ball travels 4.8 meters during that delay. The defender does not merely lose time. He loses nearly 5 meters of information. By the time he corrects, the cross is already close to Haaland's appointment. Another defender may step across to help, opening a second space. One late decision becomes 2 broken positions. So did Haaland destroy Brazil with power? Power finished the action. Geometry created it. The cross selected a future point. Haaland reached it in 0.45 seconds. The defender's delay in wrong direction pushed his time towards 0.95. The difference was only half a second, but inside the penalty area, half a second is large enough to fit an entire goal.